Hi there. Welcome to AP Physics 1 in a nutshell, Episode 1, Kinematics. You might be wondering, young physics student, what is kinematics? Simply put, kinematics is the study of stuff that moves. And that concludes kinematics in a nutshell. Well, there's a bit more to it than defining kinematics. After all, this is a physics class. There are 3 kinematic equations. I would show you where they come from, but it requires calculus. I guess this is a physics class, so I'm legally obligated to show you where the equations come from. Well, here it is. The first kinematic equation is V equals V0 plus AT. Oh wait, you are all new to this. Let's go on a quick tangent and discuss the variables to be used in kinematics. You've got your V, which is velocity. You've got your subscript of 0, which means initial. You've got your A, which is acceleration. Quick tangent from the tangent. The kinematic equations only work if the acceleration is constant. You will only work with constant accelerations in AP Physics 1 and 2. When the acceleration is changing, that requires calculus. When you have a changing acceleration, your work will look more like this. When you have a changing acceleration at different rates in different directions, your work will look more like this. And when you add a basic drag force in one direction, your work will look more like this. But that is, after all, as my calculus teacher Huff, Lord of Math, would say, that is beyond the scope of the course. Long story short, your acceleration will be constant, for now. That concludes your secondary tangent for today. Now back to your regularly scheduled tangent. Now that you know that A is a constant acceleration, you've got your T, which is time, you've got your X, which is distance, and you've got your triangle, or delta, for cool physics and Greek people, which is a change in a variable. A change in distance is known as displacement. Those are all of the variables you'll need to know for kinematics, so that concludes your tangent for today. Now back to your regularly scheduled kinematics. Now that you have the first kinematic equation of V equals V0 plus AT, there is the second kinematic equation of V squared is equal to V0 squared plus 2A delta X. And last but most certainly not least, you have the third kinematic equation of delta X is equal to 1/2 AT squared plus V0T. Anyway, there they are. There's also the range and max height equations, but you can do everything you would do with those equations with the 3 other kinematic equations. So you can use the kinematic equations to solve for different aspects of an object's movement if you know all of the values of the other variables in the equation. Each equation is very useful for different situations. Additionally, the equations can be used to quantify movement separately in each direction. For example, a kinematic equation or equations expressing movement in the x direction can be used alongside another kinematic equation or equations expressing movement in the y direction. In scenarios like this, each set of equations are completely independent of one another. For example, acceleration in the y direction does not change with acceleration in the x direction, and the same for velocity and displacement. Because of this, time is the only way to get from kinematics in one direction to another. It sounds confusing, but it will be easy to understand with practice. So that concludes AP Physics 1 Kinematics in a nutshell. There will be another video with some practice problems and another one on the next unit of AP Physics 1, which is forces. So good luck with the rest of your physics, and goodbye.